people who have been working on vehicles for very long tend to become engineers. Now, there's a lot of different definitions of the word engineer. I remember one time whenever I was at the Ford dealer, you know, sometimes the procedure of putting that silicone dielectric grease in the spark plug wires can cause you to miss something that you ought to catch. I was working on a, seemed like it was a SHO Taurus, and it had developed a misfire. And you know, those spark plugs are down in wells and stuff, and whenever I was going in there looking for that misfire, you know, I found the misfiring plug, and I had indications that the spark plug itself was the issue that was causing the misfire. And when I put the spark plugs back in there, you know, I put them down in there and did the, you know, torqued them and all that stuff, you know, made sure they were gap right. And I put some silicone dielectric grease on the, you know, just a little dab, you know, about like about half the size of your little fingernail, just enough to go up there to basically fill in the little gap so you don't get RFI between the tip of the spark plug and the wire, and also it helps to keep the spark plug boot from sticking to the plug. I mean, I hate those GM cars that have those really slick and spark plug ceramics that just vulcanize the rubber boot to the plug, where you just about have to sell a set of plug wires by default, because you know you're going to rip those things to shred. You know, I built a little thing like I had seen on the tool truck where you can blow air, you know, using a little thing. I got that in my toolbox. I'll pull it out and show it to everybody. But you work that thing down in between the boot and the plug, I mean the wire and the plug boot, and you shoot some air in there and it'll pop that thing loose from the plug. Can't always get it in on every plug, but you know what I'm talking about. Anyway, I put a little bit of dielectric grease on them, slid them down on there, drove the car extensively, didn't feel a skip. What I didn't realize and what I had missed was there was a little breach in one of the boots, and whenever it would, you know, that over a little period of time of driving it for about a week or so, the guy's misfire returned. And so, of course, I'm not one of those people that's going to throw a full set of plug wires on every tune-up job I do, you know, because it just seems to me like a total waste of cash. And a lot of times the plug wires that came on the car are better than the ones that you're going to put on there anyway. But this guy wrote a letter back to the dealership, and he said that he had read you were supposed to put dielectric grease in there. And he detailed in the letter that he wrote back to the dealership that he had, how did he put that? He had packed every one of those spark plug well holes completely full of dielectric grease. I mean, just filled them all the way up. And then he rammed the plug wires down in there, snapped them on the plugs, and he noticed that after he did that, his skip was gone. You know, and I said, oh, good grief, you know. And what was the thing about it was he signed it with his name, and underneath his name he put engineer. And so I wrote a letter back to him, and I said, nobody ever packs those things slam full of dielectric grease like you did. You still got a problem, and I'm sorry I missed it, but you got a breach in one of your plug wires, although the, you know, the one that I found, that was back before the days of misfire codes and all that kind of stuff. You know, heck, that was back in the late 80s. But the point I'm trying to make is people can call themselves an engineer. You know, some of the engineers that we meet, you know, at some of the training conferences and all, this one guy told me about an engineer he met that worked for General Motors, and the only job that guy had was designing kick panels, the plastic part that goes down there. That's all that guy did. And he was an engineer. So anyway, I mean, there's stuff you have to know to be an engineer. I'm not laying off on that, but I've also known engineers when I was working in the offshore services industry that would call themselves engineers, but when you told them to hand you a 7/8 wrench, they'd pick up a 7/16 and look at the size and see if that was the size you were asking for. Anyway, I'm getting out of off the rail right now. Well, we can actually come up with good ways to engineer a fix. Now, what we don't want to do is engineer the kind of fix I've seen some people do, where they get tired of the customer coming back complaining about the check engine light or whatever, and so they reach up under there and they find the wire that goes from the check engine light to the instrument cluster, and they clip the wire so they never see the check engine light again. Believe it or not, I've heard of people doing this. But this particular Camry here, I'm revisiting a repair that I've talked about previously. This one always smoked on startup even after sitting for a few hours. Now that's not terribly uncommon, and you know, valve stem seals leave deposits like the ones you see here. Sometimes there'll be a brown crusty deposit that look kind of like ice cream, only they're real hard and you can't really chip it off of there. And when those valve stem seals leak, a little bit of that oil gets down in there and it gets on the plug, and then whenever the plug starts to fire, it bakes that oil and turns it into these really hard deposits. And that's something that basically, a lot of times I've seen that. Now, typically if you've got one, you'll either have it whenever it's idling, it will begin to smoke after it idles for a little while, or they'll park it, and when you crank it up, it'll make smoke that goes out across the parking lot. You know, just poof. I mean, this one, well, I've seen more than one that had bad valve stem seals, and when you fired them up, I mean, they would put out a huge cloud of smoke, but they didn't smoke much after that at all. It was almost difficult to tell, but that was a lot of trickling down in there, and the oil that got in there smoked out of there. But, you know, one way or another, this was a situation that we ran into, and whenever it happens, because you've got in this part is where the air's, you know, where the fuel's flowing through on this intake. It's basically got really low pressure in there anyway, because the throttle plate's closed. The pistons are creating a low pressure area, and they're constantly drawing on this with the closed throttle plate, and they got very low pressure in here. But in underneath your valve cover, where all that oil is, at the top of this valve stem, there is actually, in other words, if you go up that way, I can't get my finger lined up just right. At the top of that valve stem, there's a seal. The reason that seal is there is because whenever the valve guides that this valve goes up and down in begin to wear a little bit, and the seals get hard, the oil that the seal is supposed to be containing from the valve cover splash area will trickle its way down and get drawn into this area right here, and it will go into the cylinder that way and all that. So basically, it's not as much of a problem on the exhaust valves as it is on the intake valve, because the exhaust valves basically have got pressure around them in the, you know, but this intake valves have got what we would call a vacuum, or lower than atmospheric pressure. So wherever the lowest pressure is where stuff is going to go to. You know, liquid's going to go from low pressure to from high pressure to low pressure, regardless of what the circumstances are. And you know, air will too. Air, oil, fluid, you know, coolant, anything like that. All right, so these seals here around those valve stems have a tendency to get kind of hard. You know, the really best ones, the one I like the best, are the ones that's got the little garter spring around them. They make a whole bunch of different ones of them and all that. But that particular thing, the splattering around under the intake, you know, will go past that and go down in there like that. Now, valve stem seals can leak enough that they cause the O2 sensor to read, to drift away from stoichiometry. One time we had put valve stem seals in a Dodge pickup, like a 91 Dodge pickup, one of my students did. And you can, on the old V8 engines, it was very easy to change the valve stem seals, but it's pulling valve covers off, putting air on the cylinder. You know, you didn't really care where the cylinder was, because you're pulling the rocker arms off anyway. So you pull all the rocker arms off, and then you've got your valves right there. When you put air in that cylinder, wherever that piston is, you know, if it's not all the way up, it may turn the crank a little bit. It doesn't really matter, because you don't have the timing chain disconnected. So anyway, you put air pressure in there. Some people will run the piston all the way up to TDC, where there's, if it's a diesel particularly, so that there's no places the valves can go, even if they try to fall. But I always like to put compressed air in there, and you know, because it'll hold the valves up in there. And you know, there's a lot of PSI that's pushing against that large valve face, and it keeps those valves up in there. They're not likely to fall out. So you put that air pressure on there. Take your valve springs loose. I got some pictures of this later in a minute. And some of these are just little umbrella seals that you just shove down over there. That's supposed to do the job. The problem with those is, if you put cheap ones on there, they can work their way up the valve stem, and then you got a huge problem, worse than you had before. And that Dodge was actually coming back, and it was throwing codes for running rich, because so much oil was going by the valve stem seals that it was, you know, making it smoke, and it was actually skewing the oxygen sensor readings and causing it to, there was just all kinds of problems as a result of that. But we had to go back in there and put some better valve stem seals on there. Unexpected side effects of valve stem seal deposits are whenever the EGR is flowing, sometimes it will cause a surge. if you've got valve stem seal deposits. Now, sometimes you'll think, well, if I unplug the EGR valve and it's quit surging, then that means there's something wrong with the EGR valve. Well, not always. If you look at anytime you got a situation like that, it's best to pull the plugs out and look at them, because you may have valve stem seal deposits on the plugs, and that, whenever you put some of that inert gas from the exhaust back in there, you're only recirculating about 5% of it anyway. And that's above idle now. It doesn't do this whenever you're idling. It's never supposed to do EGR idling on a regular gas burner. So, but anyway, what you got here is when that EGR is flowing while you're driving down the road, you may feel it, doing a little surging. And I've actually unplugged the EGR valve and cleared up that surge, and then pulled the plugs out and found valve stem seal deposits, put new plugs in it. And also, if you find valve stem seal deposits, does that mean you need to do something about that right now? Well, it depends on how quick the valve stem seal deposits got there, because they may have taken them 10 and 15, 20,000 miles to get there. And you can actually just swap out the plugs, and if you trade out the plugs and you drive it and it doesn't surge, when the EGR starts to flow, then you can tell your customer, well, we're eventually going to need to put valve stem seals in here, but just drive it for a while with these new plugs in it, and I think you'll be satisfied with it. If you tell somebody something like that, they're a little more comfortable than they are if you just, try to sell them the whole farm right out of the bucket, And all right, so what we're looking at here is we want to do what we can to do this with a minimal amount of invasive tactics. Now you see that this is a slick little deal. You drill a hole in a wrench, and you basically use the fulcrum bolt or point or stud or whatever, and you can actually pull on that wrench and it'll release those valve keepers. You can get them out of there. Of course, you need your air pressure going in there before you do that. They make a tool that you can buy real cheap to do this with, though, at the parts store. I mean, you don't really need to do this if you can do this. You see what I'm saying? And so that thing right there, you can buy one of them for like $10 or something. I don't remember how much they are. I mean, I haven't bought one in a long time, but they work really well on these old V8s like that. And of course, after you get it off, you put your valve stem seal back on there, and then you put your valve back in and make sure the keepers are in there. Tap it. The keepers right in those little grooves right there, and they're cone shaped so that they can come off here. And they've also got rotators under there that actually turn the valve while it's opening and closing to keep it from wearing the seat out as quickly and all that kind of stuff. But that's another story. Now, make sure you use good seals. This is an important point. I mentioned that earlier. This is a good seal. This is a crappy cheap seal, which I don't like, although a lot of engine builders use them for years. Some of them got little O-rings on there, but I really like the ones that's got garter springs or than real substantial seals, because they're more likely to stay where they're supposed to be, and they're more likely to keep the oil out. All right, now this 93 Camry that belonged to a friend of mine, this is that same Camry I was talking about, where he called me one time whenever he was about 10 minutes out from work, and he said, my engine on my Camry overheated, and I'm out here at this little old abandoned country store parking lot, and I went over there. Immediately I left somebody in charge of the shop, and I went over there, and whenever I got there, whenever he was cranking it up, had that stinking sweet smell that you smell when there's head gasket issues and all that. And I looked, and his radiator had split all the way across the top, and he had lost enough coolant to where it got really hot. And I said, this thing right here, I'm afraid it's got a blown head gasket. We may have to put a head gasket on here. Hopefully it hadn't warped the head. Because I could tell, the smell I'm talking about. If you smell that stinking, sickly sweet head gasket smell when one is blown a head gasket, you'll know what I'm talking about. And this one was doing that, and it was puffing steam out when you spin it over too. I said, this is terrible. And so he went in and called a wrecker, and we got it over there to the shop, and I was going to show the students, this is what a blown head gasket looks like. Now, a couple, 3 hours had gone by. Got through the classroom session, went out in the shop, watch this, I'm going to show you what a head gasket looks like. Whenever, pull the radiator cap off that darn thing, and we fired it up, and there was no indication whatsoever that there was any kind of a blown head gasket. I would have sworn in a court of law after seeing it out there on the road that it had a blown head gasket that was going to need to work. I've actually been, you can get fooled like that. Just if you just look at one piece of data and don't let some time go by. There was another similar situation where we did seemed like it was an A4LD transmission on a Ford Ranger there, but rebuilt it. It's got a huge valve body with all those valves in there, aluminum and all that kind of thing. I never did like those transmissions much. Put it all back together, got it all buckled up and everything, and when we got through with it, you know, we always torqued the valve body with little inch-pound torque wrenches and follow all those procedures and all that kind of thing. Made sure the gaskets were good and that kind of stuff. So when we got through with it, it was just not working right at all. I mean, it was like there's so much wrong with that transmission. There's all kinds of cross fluid leaks between passages or something. I was not even sure what was going on because it ran so. It was just horrible. And so I said, let's just leave it over here in this stall, and we'll move it, put it on the other lift on Monday morning. This was like on the last day of our class week. And I said, then we'll pull it back out of there, and we'll see what we got to do to straighten this mess out that we've made. And so whenever I got in that truck to pull it around to that other service bay, I can't even describe what it was doing. It just, everything was wrong with the way it felt whenever I was trying to drive it right after we first put it back together. But we got it good and hot, you know, warming it up, trying to make sure everything was going to do what it's supposed to do. And then we let it cool off, and then when, you know, 2 or 3 days later, we pull it around. That thing shifted like a brand new transmission. Totally astonished me. And I called this guy that had a transmission shop over big town up the road. This guy I used to talk to when I had questions that I didn't think I had good answers to. And he said, yeah, I've run into that before. He says, what happens is the valve body is slightly warped a little bit when you pull it off of there. And then when you buckle it back up, until you heat it back up and let it cool down, it doesn't have time to, you know, straighten itself out and pinch off those passages. If somebody just told me that, I think they were filling my head full of nonsense. But I called this buddy of mine that I placed at this Ford dealer that does so many transmissions, and I asked him about it. He said, oh yeah. He said, I've run into that. He said, the first one of those, I thought I'd done horrible things wrong, you know, but he says, after a little while, if you drive it, heat it up and cool it down a little bit, it seals off all those passages and everything starts doing like it's supposed to. That's the craziest thing I've ever, you know, sometimes there's stuff you think you know that you think you've seen enough to where you can't be surprised, but that was the opposite. Anyway, this car, he came to me and he said, it makes a big puff of smoke and goes all over the parking lot when I first started. And I said, well, I know what that is. You know, that's those valve stem seals. So let's see what we can figure out. All right, so there's cam followers here, right, down in here. And these valve springs are down in a dadgum hole. And the cam follower on those, incidentally, each one has got its own measurement. So when you pull those cam followers out of there, you better keep them in order, because the measurement between the top of that and the little part that rides against the valves is not the same on every cam follower. You got to make sure you put them back like they were. Now, is it going to make a big problem if you get them mixed up? I don't know. We always try to put them back the way they came. And, you know, it's kind of like painting a drive shaft so that whenever you put it back in, you don't put it back in a different spot than where it was, so you won't create a little vibration that you didn't expect or whatever. But anyway, there's very little smoking while driving. And now, I was pretty familiar with this because I'd worked on these Volkswagens. Now, they had a similar setup, only they had shims on top of those carriers that we had to swap out when we were adjusting the valves. And believe it or not, we did a heck of a lot of valve adjustments at the Volkswagen place. Adjusting the valves on a Sirocco or a Rabbit like this, or even a diesel Rabbit, it paid $18. That's how much it cost the customer to get the valves adjusted on one of these. So we had to jerk the valve cover off and do all them, you know, turn the engine over while we were using the little go, no-go feeler gauges, and then you'd have to have, you know, run this little thing around there to push the cam follower down, use some special pliers to get those shims out, measure the shim or look at the number on it and put the one back in there that would put it within specs, all that kind of hogwash. But I made quite a bit of money though adjusting those valves, because you get where you can do it really fast. You know, if you do something a lot, you get where you can do it really quick. And now, when you remove the cam follower on these, you can see that these are down in a hole, and you can't use a conventional valve spring compressor to get to them. Now, I did on my last little short mashup video show you how you can take a magnet and put it in a socket and just whack it, and those keepers will jump right out of there. However, putting them back is tricky. You know, you're going to have issues doing that. They do make special tools for that, and they swear up and down will work really good. I've never had really good luck with those. But anyway, the Toyota dealership, when I asked them about it, they say, we always pull the head off and send it to a machine shop. And I said, where there's a will, there's a way. We can figure out a way to do this. Well, I went on the tool truck when the guy showed up. He just happened to be there that day. The Mac guy used to come by. And he had this thing on his truck, a TOY 165 made by AST Tools. I don't know if you can still get this or not. But this little thing right here was made to use with a conventional valve spring compressor with the head on the bench. So I bought this little thing right here. I don't remember what it cost, but I bought it, and that's what it was specifically designed for, was that. And so I actually created a little fork thing, and I got this little, it was a C-clamp I had that was all bent anyway, that somebody had used doing something with it. And I got this plate, and I drilled a hole and tapped 6mm threads up in there, and I put a lot of holes in this plate, and I fixed it so that this bolt was tightened up in that hole, and the plate would spin around, you know, so you could always find a hole that would line up. All right, I made that so it would slide on here. I welded a socket. This is one of them Whitworth sockets that don't fit nothing except old British motorcycles. I welded it on there, and I put it so that I made myself this valve spring compressor to use on that that thing, and it worked. Now the scissor gears, ingenious gear lash handler that Toyota came up with. Lexus used this, and I think there's some other manufacturers using it now too. Well, before you take the camshafts out of there, there is a hole. You're supposed to put a 6mm bolt through there and keep those cam gears loaded. Now, if for some strange reason you forget to do that, and they pop that little spring inside there, will move the teeth back to where this tooth is back here in relation to that one, and when you crank it up, you'll hear under the hood because it makes terrible rattling noise. And so all you got to do is get a couple of pairs of channel locks and reload the gears. You're just moving one teeth back, and you put that bolt in to hold it. That bolt holds it in place. Don't forget to take the bolt out. After you put the thing, get the camshaft back in there, line up your little timing mark. You might notice that whenever you got gear driven, you got a timing belt pulling it out here, and then this camshaft driving that one. These camshafts are turning in opposite directions, see, so that had to be engineered too. Anyway, don't neglect the scissor gears. Now, on the Volkswagens, they had a 0 grind on those things, and then they had a +5 and then they had a -5. It was slightly different angles, and you had to find one that didn't have any lash at all on those Volkswagen Bug. This is the old Bug camshaft right here. That's the first time I ever knew anything about that. My dad always had to, when he was building a VW Bug engine, he always had to get the camshaft that would fit real snug where there was no lash whatsoever, because if you build one with lash, you're going to wind up with hold on, you build one with lash, you're going to wind up with a rattling noise in there. It's just awful. All right, so the old, but to combat that lash, the older engines, a lot of them, some of your General Motors cast iron, transverse engines were like that. They had a sort of a phenolic material of some kind around the outside of this that the gear teeth were cut into, because it would operate a lot more quietly against that steel crank gear. This one here, you're seeing a gear for a 2.8 liter Mustang engine that's like 74 to 78, whenever the little Mustangs first came out. And they had those phenolic teeth on those too, and after a period of time, those phenolic teeth would bust off of there, and you'd wind up having to put a metal gear on there. Sometimes it'd make noise, sometimes it wouldn't. But they tried to make it so that there was no gear lash at all, yet it wasn't going to burn up because it was too tight either. This right here is a gear set that you can get from some of these racing outfits like Summit Racing to replace the timing chain setup on some of your V8 engines, like your 350s and your 302s and all that kind of stuff. All them, they make those. But sometimes those darn things are noisy too. But because of the fact that the camshaft is hard and easy, and it's always trying to bounce back and forth while it's opening and those valves are closing. When it's opening valves, it's hard to turn, and when the valves are closing, it tries to move. So that's why when you're trying to turn your camshaft with your breaker bar, it goes boom, 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 like that. And those gears have got to deal with that, okay? And so that's why the scissor gears were necessary, and that was a very ingenious way that Toyota came up with to deal with that. Got to hand it to those people. All right, we're going to make it work. Well, let me back up here. That little tool that I built worked famously on that little engine in that red 93 Camry, which was the old 2.2. All right, and so the 2.4 has got similar valve configuration, but the camshafts are driven by a chain with a hydraulic tensioner. It's got variable valve timing on the intake camshaft, and the labor time is 17 hours to R&R the head on this. Factor in the machine shop work and the gaskets, and this is like a $2,000 repair at the dealer. All right, so we give it a try. Let's just give it a try. We got nothing to lose. After we'll pull the head off and send it to the machine shop. But let's just give this a try. So we dive in and see what happened. If we had to pull the head off, we'd be no worse off. All right, so first thing we did was we lined up, there's your 10-degree mark, lined up that on the 0 degree. Made sure we were on compression stroke number 1, right? Okay, the balancer, see that little tiny arrow on that cap right there? I mean, you'll miss it if you're not looking for it. And then you got this on that variable valve timing thing. All right, so lined all that stuff up. Let's line that stuff up really, really good. And let's make sure it's right. And then we go ahead and pull the camshaft off. Now David removed the timing chain tensioner, which is on the rear of the head. This is the guy that was doing the work. And it's got an annoying wire harness looming in the way, you know, down there. But anyway, you pull it out of there, and that's what it looks like. You have to actually load it and lock it when you're putting it back in. It's funny to me, David had a new set of Craftsman tools that he had got. It was part of the tool list that I had for the college over there. And he was a young boy, but he's the same one that I was talking about the last time that run the nitrous in through his Ranger several times before he blew it up, you know. Same guy. He was a piece of work. And so, and he's also the one that was sitting in my office, you know, on that one video, you know, David's, you know, whatever. Anyway, it's David's phone call or Buck's phone call or whatever the name of the video is. So, and I think I told you that story before, but it's still funny to me. I took somebody, you know, if you take a little Craftsman 1/4-inch drive ratchet and you don't put the socket all the way on it, you put a lot of torque on it, you'll twist that little end of that little square anvil off on that ratchet. Somebody had done that with one of the ones that belonged to the school, twisted it off and broke it. I had my desk drawer next time I went by Sears or whatever. I was going to replace that ratchet, you know, having to replace the ratchet because it was broke. And it was brand new. It was just like the one he had. And he was out there working on his Camaro out there while everybody was watching him that one morning before class. And I went out there, and while he wasn't paying attention, I swapped out his new ratchet with the one that had the busted anvil on it, you know. All right, so I had his in my, you know, where you couldn't see it, hold it in my hand or in my pocket or something. And so he grabbed that ratchet and he went to put a socket on it, and when he saw that it was, you know, not, he says, "What the heck?" He had this shocked look on his face, and then I laughed and I gave him back his ratchet. And he shook his head and he says, and this is exactly what he sounded like when he talking. "I was going to hurt somebody." Yeah, this guy was 18 years old. He already had a voice that deep. He was just a lot of fun. He's a real smart guy. He's a mechanic now too, and does good work. Well, he pulled the cam bearing caps and disengaged the camshaft from the chain by removing the exhaust camshaft bolt, then removing the camshaft from the gear and setting it on the bench. And we applied air and we used our tool. See there, we are using our tool right there. See how we could turn that around and find a place to bolt it down. And it wasn't a lot of energy that it took, but you just screw that little thing down. Remember, this is welded to that plate, and that plate was, I ground it so that it perfectly fit that nice and tight. Pushed it down in there. You got a lot of room to work here. You get your keepers out, lift the spring out, put the seal on, pull out the old seal, put the new seal in there, put it all back together, one at a time. All right, and this is kind of what they look like. These seals were all hard and cracked and all that kind of stuff. No wonder they were leaking. With both camshafts out of the way, the cam follower lifted out of there. You got to keep them in order. And when the little cam followers, little buckets, you know, that slide in up and down in here. It was a simple matter to put the garter, spring, valve, stem seals on, put it all back together. And so, now we put the camshaft back in time, and in time it took some doing, but we tinkered with it and got all the marks lined up. We got them lined up just like they're supposed to. We had, you know, little colored gears, colored teeth on the chains and all that kind of stuff. Got them all lined up. Now you see we had to install the intake camshaft in time first and mesh the exhaust cam gear cover with the chain. Finally we installed the exhaust camshaft, settle the journals into their saddles. We have to keep those in order too. Don't mix up your little journals because they're not all the same. You know, you might think they are, but they're not. And so if you actually mix those up, you're in big trouble. So most of the time they got numbers on them, but you need to number them if they don't have numbers on them, or if you can't read the numbers, or if you're not sure, or if you want to make sure, make darn sure you put the cam saddle caps back where they came from. That is really, really important. Cam followers, cam saddle caps need to be in order. When you take them off and you put them back on. And so I'm talking about these things right here that you put on there that this cam spins in the journal. All right, we got them all torqued up. You see that mark right there, that little arrow, and there was a mark on the gear that you can't see from here, and it had that little arrow right there. And so then I just circle those. We inspect those little teeny tiny arrows right there. It's amazing to me that they're as little as they are. You expect them to be easier to spot than that. But you know, you can look in the shop manual procedure and it'll tell you they're there. Okay, so with the chain tensioner loaded and reinstalled and then unloaded with a long screwdriver, we were ready to valve cover this baby and verify the repair. Incidentally, here's a picture of the timing mark. The timing mark there lines up with that arrow, and that right there on this variable valve timing, it lines up with that. And that's, we got all of that just like it was supposed to be. You see those timing marks right there. All right, it was successful. We had little pitfalls and stumbles along the way. We proved that you don't have to pull the silver head on the 2000 on that vintage of 2.4 liter Camry to replace the valve stem seals. And we did another one after this, and we did it a lot faster because we managed to make it happen. You know, I didn't put my coffee pot up here today because I've already had my coffee. And so I just wanted you guys to tell you how much I appreciate your comments and your views and the new subscriptions that I get. And I hope this helped, and I hope you learned something, and I hope you enjoyed watching this as much as I enjoyed it. Although if you look at the watch times, a lot of the times people will start watching it, and about 6 or 8 minutes in they'll quit watching it according to the analytics that I see on YouTube. But that's okay. If you watched it all the way till now, I really appreciate it, and we'll see you next week.